Advantages. To simplify the logic, simplify the program logic. To call the code from several programs. To call the code several times in the same program. Debugging of the code. Debugging is a tool here that helps to know how the system executes the program result. Executes the program result. Of code. Error handling of the code. Debugging is not finding errors in the program, sir. It is a tool for knowing what has happened in the program. Error handling in the logic, program logic. We have 4 techniques. One is include, subroutines, function modules, and macros. Today we start with the macros. Macros is abbreviation of code. Macro is a name given to the abbreviation for the code. Advantages: it can be called multiple times in the same program. It cannot be called from other programs. And no debugging is possible here. No error handling. And no nesting of loops. Nesting of loops means loop inside loop. Here the syntax is like this: define a macro. Define is a keyword, macro name, and statement block, end of definition. And call a macro directly with the macro name. Let us see some programs on the macros. I go to the ABAP editor, ZHEM, macros, macros examples. Define sample. I want to write one statement here, Raj. End of definition. This is the code I am writing and giving the abbreviation name as sample. You can call now any number of times sample in the same program. So it is going to display Raj for 3 times. Same, I just change a little bit. example. Instead of writing sample 3 times, I said do 5 times example. Example is a macro performed 5 times here and do. Do inside do is not correct, but one time you can use the do loop. Activate. Hurry is displayed 5 times. Now I want to add the numbers here with the macro. I just want to give 2 numbers and add it using a macro. Parameters B type integer, data C type integer. Now we are defining a macro. Define ADDT C equals to A plus B. Write C. End of definition. And you are calling the macro directly with the name ADDT. So when you give the values, it will calculate A plus B. Now I change a little bit of this program using the parameters. We are defining the parameters in a different way here. I want to do any calculation now with the macro. CALC is the name of the macro. Here I am not doing A plus B now. Instead of doing A plus B, I say ampersand 1 for A, ampersand 2 for plus, ampersand 3 for B. A plus B is given like this. Address is storing A plus B like this. Write C is the final result. Now you are calling the macro CALC and performing A plus B. When you say A plus B, this will be A, 2 will be plus here, B will be 3. So A plus B is calculated and it is going to display C. Again you can say A minus B. Again A star B. A by B. Like this you are performing same operation several times. I can use chain operator and give like this. Yeah.
And N1 and N2, these are all the parameters?
Yes sir, these are not the parameters here. These are the calculation which you are doing. Correct.
What exactly?
Yeah. Here A is taken as 1 here, which is storing the address of A, plus address is stored in 2 here, B is stored in the 3. If you have,
How the system will get understand?
yeah, when you are calling this macro, first it will go to this macro CALC and take this A plus B as 1, 2, 3. Whatever the sequence you have given here, in the same sequence, the 1 is taken as A here, 2 is taken here as your calculation, and 3 is taken as here B, because these are the values you are passing. So A plus B is performed at the runtime. So you can give like this also, with one chain operator, all these things. I want to simplify further like this. A is common, plus B, minus B, star B, slash B. Give spaces. Space is more important. Save check. where it is telling period is missing, expected after full stop. This is correct. This is correct. Here,
Can you please check A type I, comma, is it?
this is comma only.
Okay.
No problem. Actually, here it is telling either in this line or this line. Comma is given. Is it comma, sir? Period only, correct? Here, sir, I should give period. This is missing. This period is more important. I am giving some values. It will calculate all the operations: addition, subtraction, multiplication, division. So this is the macro. Macro is only used for displaying the statements, not for any other purpose. We are having the subroutines. This is the second topic here. Sequence of steps that may or may not give any result. In other languages, subroutines are known as procedures. Here we are calling as subroutines. How to define a subroutine now? Two types of subroutine. One is internal subroutine. The second one is external subroutine. It is defined and called in the same program, like macros. It is not available to other programs. When I go for external, it is available to other programs. It is defined in subroutine pool and called in executable program. It is available for several programs. So the syntax: define, subroutine name, parameters. This is optional, and statement block, and end form. How to call it? This is a define subroutine. This is calling the subroutine. Perform. Perform is to call it. Here we have to use forms or not form. Define, form, subroutine name. Form, perform. Perform subroutine name and parameters. Parameters are optional in both the cases. Form is to define it, perform is to call it. I write one small program now. This is the internal subroutine. Type executable. parameters A type integer, B type integer, we are defining the form always on the end of the program always. Please note, subroutines are always defined at the end of the program. So I am defining at the end using A, B and C. C equals to A plus B. Write C. End form. Form is defined at the end of the program and perform is called in the middle of the program. Perform ADDT using A, B and C. This is how we call it. This is to define it. I just change a little bit of the program, internal subroutine. Here, if you are noting this program, the parameters which are defined here with this form statement are called formal parameters. Parameters that are defined by form statement are known as actual parameters are the parameters that are defined by perform statement. Actual parameters. The difference is here, formal parameters occupy a different memory location, and actual parameters occupy different memory location. They are not stored in the same place in the memory, different memory location. That is, they are not stored in the same place in the memory. So I change a program like this. X, Y and Z. This is formal I am changing. Z equals to X plus Y. And write Z. Now A is our X, B is our Y, C is our Z. This way and that way both are correct, sir. One is formal, one is actual. You can define formal values, correct. These two are not the same always. You can give same values also always. There is no problem here, but the reference is done here. Formal and actual parameters are different always. Now we write some another program. Differences between formal and actual parameters by value, by reference, by value and return. One program I am writing for by value now. The syntax is different for all these three. All are internal subroutine only. This is by value syntax. Very simple program. Data a type integer. The value of a is given as 20 here. Before doing anything, value of a is, obviously a is 20. We are defining the form now using value. Using value is the syntax. Using value p of a. P of a is a parameter passed to the form. You can say a also. I am changing this parameter as p of a. Now 20 is changed to 15. Right, in the subroutine, value of a is, I just want a value only, not p of a. End form. Perform now. SUBA using a. This is the syntax, using a, using value. After performing, I want to know the value of a. After calling subroutine, value of a is, this is 20 only, sir, because before you are doing anything, it is 20. It is changed to 15, but it will show only 20 here. By value will never change the value. So let us see. See, 20, 20, 20. The rule is, when you are saying using value, it will never change the value. I'll write the rule here. By value means the value remains unchanged for all the subroutine. That means before calling subroutine, all will be 20 only. Second rule now, by reference. Same program, by reference now. The syntax is quite changed here. Very small change in the syntax. Instead of saying using value, you just say using p of a. So it will change the value to 15 here. Earlier it was fixed, now it is not fixed. It will change this to 15. By reference is, the rule says that the reference value is always used, not the original value. Whatever you have changed, it will affect. So, by reference. Value is used for all the subroutine. Here, before calling subroutine, in subroutine, after calling subroutine. 15, 15. Now the third rule, by value and return. First you are saying it should not be changed. Second you are saying it should be changed. Let us see by value and return now. Instead of using, you have to say changing. Here also changing value. So now the rule says that it will be changed from the next time onwards. Here also it will take here 20. After coming out of the subroutine, it takes 15. 20, 20, 15. It is changed from the next time onwards. In the subroutine also it takes 20. This is by value and return. Please observe the three syntax, by value and return. The value is changed from next time onwards. After calling subroutine, 20, here also 20, here it is 15. In the next class, I will continue external subroutine. Just see this one, today all these programs, and very important function modules. We do one example, external subroutine also. Try all these examples. I'll give assignments in the next class for this. Yes sir, we stop here. We continue tomorrow with our discussion.
Sure.